Out of Jupiter's 53 named moons and 26 unofficially named moons, Jupiter's Io has got to be the strangest. As the fourth largest moon in our solar system, Io is the only object outside of Earth that is observed to have active volcanoes. In fact, Io has hundreds of active volcanoes, making it the most volcanically active object in our entire solar system. According to NASA, the moon's volcanoes have reached temperatures upwards of 1,650 degrees Celsius. However, the Io moon also fosters an average surface temperature of -130 degrees Celsius. Thanks to this massive difference in temperature, Io is covered in sulfur dioxide snowfields, alongside volcanoes with 400-kilometer high plumes. As one of the hottest and most active moons in the entire solar system, Io puts on quite the show. The moon put on such a show that it was discovered in 1610 by Galileo, before its naming in the mid-1800s. Even with its discovery, there wasn't any information on the moon until NASA's 1972 launch of Pioneer 10. It took the space probe a year to fly past Jupiter, where it discovered a belt of radiation surrounding Io, suggesting a potential atmosphere. That was about all we knew until the 1977 launch of the Voyager program. With Voyager 1 and 2, NASA obtained a bit more insight into Io, discovering the moon appeared utterly distinct from the other Jupiter moons. Compared to the dark surfaces of moons like Callisto, Io stood out with its orange coloring and dark spots. NASA had initially thought the dark spots to be impact craters, alongside a substantial 1,000-kilometer ring. However, when Voyager 1 moved closer in, NASA found Io's surface was completely devoid of impact craters, and instead, the dark spots were massive plume deposits from gigantic volcanoes. It got even stranger when Voyager 1 moved to just 20,000 kilometers above Io's south pole. As the probe's cameras attempted to capture photos 40 times more dense than previous captures, Voyager 1's data transmissions greeted NASA scientists with significant smears and narrow exposures. As it turns out, Io was home to extreme radiation, which completely knocked Voyager 1's internal clock out of rhythm. Additionally, scientists were shown a surface coated in volcanic calderas, mountains that would tower over Earth's, and extensive plains. These plains were so vast, in fact, that they were thought to have grown from Io's volcanic output, which had covered up the moon's buried craters. With Voyager soon after sailing away into space, NASA immediately went to work on the Galileo spacecraft, especially following their discovery of how strange Io was. After being delayed for 7 years, Galileo ended up launching in 1989 and arriving at Jupiter 6 years later. The first thing NASA tested with the arrival of Galileo was Io's magnetic field. Using magnetometer data from Galileo and analysis of Galileo's Doppler effect around Io, scientists determined that Io had a large iron core, and now, with more certainty, a magnetic field. This was a significant discovery, especially considering iron cores are usually reserved for more giant planets that have managed to pull in metal with their more substantial gravity wells. With the rest of Galileo's visit near Io, the probe discovered a new lava flow, significant eruptions, and, oddly enough, a plume that shifted 75 kilometers in the 17 years since the Voyager probe passed Io. In a situation similar to Voyager's, Galileo's mission was extended to capture photos corrupted by unexpectedly high radiation levels. In this situation, though, Galileo faced hardware issues from the mass radiation. As such, NASA extended Galileo yet again, this time capturing data that suggested Io was enveloped in Jupiter's magnetic field versus its own. In more recent times, NASA's New Horizons space probe captured Io enduring a volcanic explosion, and on top of this, the Gemini Observatory discovered that Io's atmosphere collapses during Jupiter's eclipses. As it would turn out, Io's sulfur dioxide atmosphere collapses when Jupiter's shadowing of the moon freezes the atmosphere. This happens every 0.9 days, which is half of Io's 1.8-day planetary orbit. Remember, Io's surface temperature averages at about -150 degrees Celsius. So when it passes into Jupiter's shadow, the moon ends up cooling to -168 degrees Celsius, which actually freezes Io's atmosphere, turning it to frost. Yes, the moon's atmosphere actually freezes and almost snows back to its surface before sublimating to a gaseous form. That's incredible and incredibly helpful, as this discovery helped NASA better understand how Io manages to hold its own atmosphere. See, sulfur dioxide freezes at around -73 degrees Celsius. That's 77 degrees higher than Io's average surface temperature, meaning that the atmosphere should freeze over more often than not. The exciting thing is that Io's oddly placed volcanoes prevent freezing. Through their 300-odd kilometer high volcanic plumes, which burn up to 1,650 degrees Celsius, Io manages to stay warm. Well, atmospherically speaking. Still, while NASA can explain Io's primarily sulfur dioxide atmosphere from freezing, that's about all. We globally still can't explain why Io's volcanoes are where they are, how Loki Patera, the 8,100 square mile lava-filled depression, exists, or how Io can even maintain its oddly built atmosphere. After all, this is the most volcanically active body in the solar system, and we don't know how it can even manage to earn that title. Io bobs up and down upwards of 100 meters as Jupiter's gravitational pull affects the moon during orbit and coats craters with fresh lava. In a study named Io, Volcanic Thermal Sources and Global Heat Flow by Veeder & Company, some of Io's dark spots have an individual heat flow output of more than 10,000 gigawatts, or 10 terawatts. Earth's total heat flow ranges from 43 to 49 terawatts. That means the 3 dark spots on Io potentially supply the same heat flow as Earth's core to atmosphere. Speaking of these dark spots, let's now look at Io's volcanic surface. Remember, with some volcanoes boasting 1,650 degrees Celsius flows, Io is constantly evolving in a very fiery way. Io may be 4.5 billion years old, but it definitely doesn't look like it. Like sketchy beauty pageants in movies, Io is constantly getting a facelift. The moon's massive volcanoes and sheer number of them are consistently coating Io with a new surface. Some estimates have even said that Io's oldest viewable surfaces are just a few million years old, just 0.1% of Io's total age. With Io's viewable aspects being constantly renewed, we have virtually no information on how it was created or its history. So NASA has not been able to say anything about Io other than occurrences in the last million years. They haven't been able to get any information about its surface thanks to the immense electrical current and insanely powerful radiation output. And even if they got near the surface, it could be as recent as 0.1% of Io's existence. There might be no way for NASA or any other space agencies to learn about Io's past without quickly making their way several kilometers into the surface. But again, volcanoes are constantly rewriting history, meaning that too long of a mission would be a very, very fiery death to a vehicle. Plus, there's no significant evidence of Jupiter's impact on Io. However, it's the planet's 3rd largest moon, and Jupiter's gravitational pull creates some seriously odd effects on the moon. For example, several 100-meter shifts occur often, and Io adopts Jupiter's own magnetosphere, which changes all the time. Io's own atmosphere freezes and returns to the planet as frost, simply because Jupiter passes between the moon and the sun once a day. With an effect similar to the moons on Earth's oceans, will Io eventually have lava tides? Speaking of which, you may be wondering, why is Io volcanically active while the other 3 Galilean moons aren't? Why does Io theoretically hold the least amount of water out of any object in our solar system? How are the Galilean moons formed like planets? And there are still many more questions, and they're all towards a moon that has been studied for nearly 50 years. NASA has sent multiple missions directly to Io, or redirected towards Io, and we now have more questions than at the time of those launches in the 1970s. So, with all that being said, what do you all think? Thanks to Io's forever-changing surface, will we ever be able to collect information on its history? Or will our attempts to discover the strange moon be covered by the same 1,650-degree lava, which has also covered craters? It could really go either way, although we'll need quite a few innovations to get there. After all, fighting against incredibly high electric currents, extremely high radiation, volatile surfaces, high temperatures, Jupiter's gravity, and much more means quite a fight for any future Io learning events. Anyway, Let us know what you think in the comments down below. And don't forget to subscribe to the channel for more videos just like this every week.